filling in the blanks here with notes. Quadratic function written in standard form looks like this. ax squared plus bx plus c equals. It can be 0 or y here. Sometimes you'll see it equal to 0, sometimes you'll see it equal to y, whatever. That's the general form. Notice it looks very similar to standard form of a line, which was ax plus by. Okay. In that case, it was equal to c on the other side. I mean, ax plus by equals c, no squared. Okay. So the graph of quadratic is U-shaped. That might be an upside down U or a regular U. And it's called a parabola. The vertex is the lowest point if it opens up. Oh, there's already the word point there. Yeah. The lowest point of the parabola if it opens up, and the highest point if it opens down. So if it looks like this, you have a low point. If it looks like this, you have a high point. We already talked about this. We talked about the swing set thing. So, you know, when you just barely touch the ground, that was the low point. If I throw a ball up in the air, there's going to be a point in space when it's not going up and it's not going down. It hits that highest point, and then it comes back down to earth. Okay? Hail Mary pass in football. It's going to go up and eventually come back down. Three-pointer goes up, comes back down. Okay, there's an arc to it, a parabolic form. All right? Now, the axis of symmetry. The axis of symmetry, okay, is a line that passes through the vertex and splits the parabola in half. Okay? It's only symmetrical, the two sides match. Okay? So the left and right side of the parabola match if you folded it over that line. Okay, so the axis of symmetry splits it in half. Now, the domain. I can spell. Domain, D-O-M-A-I-N, of a function is any number you could plug in for x. So in this case, the domain will always be all real numbers. That funky R with two lines. In other words, if you have a parabola, it's just going to keep going left and right forever and ever. Okay, so you don't have to draw this. But if I have a parabola that does this, it's going to go on. These arrows mean forever and ever. It's going to go a little bit more to the left, a little more to the right, and it's going to keep going left and right forever. Sometimes very steep, sometimes really wide, but it's going to keep going left and right forever and ever. That's why the domain, which goes this way, left and right, the x-axis goes left and right, that's why it's all real numbers. The range of a function is any number you can get for y. So in the case of a quadratic, two things could happen. It can open up, okay? Happy smile. All the y values are bigger than the y-coordinate of the vertex. So y is greater than or equal to the y. The y-coordinate of the vertex. Okay, so once you know the vertex, that's the lowest point, so the range goes from there up. If it's opening down, like so, you have a vertex here. So opening down, all the y values are smaller than the y coordinate of the vertex. So y is less than or equal to the coordinate of the vertex. Sorry, the y coordinate. Okay. So, standard form is, we already said that, y equals ax squared plus bx plus c. Okay, that's standard form of parabola. Like I said, you could either c equal to y or sometimes equal to 0. What? What?
Nothing.
Okay. If a is positive, then it opens up. So I talk about it's a smile. Happy. Positive. Going this way like a smile. Okay? If A is negative, that's a frown. So it's opening down. Okay? Happy smile, frown is down. The vertex has an x-coordinate of x equals the opposite of b over 2a. And that a and the b come from the standard form. So you take the opposite of whatever b is and divide by 2a. Just the way we did with the quadratic formula, identifying the a's and b's and plugging them into the formula. Same thing here. To find the y coordinate, you're going to plug x into the equation. So after you find x, plug it back in, and that will give you y. And the axis of symmetry is a vertical line through the vertex. Again, it's going to cut it exactly in half. Okay. So, got a little cheat sheet here. You're going to use the opposite of b over 2a to find the x coordinate of the vertex. You're going to find the y coordinate by plugging in x. That same x we just found. You're going to find the intercept from the c value. That c is the y-intercept. Okay, so ax squared plus bx plus c. C is the y-intercept, always. You're going to make a table or factor, which we have talked about and we'll review again tomorrow. Okay, you're going to make a table or factor. Put the vertex in the middle if you're making a table. Okay, put the vertex in the middle. And you put some above and some below. So you're going to choose 2 x's below the vertex and 2 above. So in other words, you'll have 5 points. And you'll fill in the table by finding the y's of each of the x's. So it's very important. You're going to find 5 points. The vertex, 2 above, 2 below. Then you're going to plot the points and connect them. And you're going to make sure you make a U, not a V. Okay, so let's do one. Okay. Okay, so decide how each opens first. So is A positive or negative? Positive, so that's a smile. So it's opening up. Okay? Just like we did before, let's identify A, B, and C. What's A? 1. What's B? What's C? Negative 8. Be careful, it's negative 8. So our vertex is going to go right here, right? In the middle, we said? Okay, so let's find the vertex. X equals the opposite of B over 2A. Right? So, that's negative 2 over 2 times 1, right? B is 2, so the opposite is negative 2. So what's negative 2 divided by 2? 4. Huh? Negative 1. Okay? So now we're going to plug negative 1 in up here. So negative 1, that looks horrible. Negative 1 squared plus 2 times negative 1 minus 8. Again, this is where you don't want to use calculator, you want to use your brain. What's negative 1 squared? Positive 1. A negative times negative is positive. Okay? So that's 1. What's 2 times negative 1? Negative 2. What's 1 minus 2? Negative 1. And what's negative 1 minus 8? Negative 9. So, where's my vertex? Negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. So my vertex is negative 1, negative 9. The axis of symmetry is going to go right through that line. So everybody do your best job to put a dotted line like so. Remember, vertical lines have an x equals formula. Because x is always negative 1. Look at it. Negative 1, 0, negative 1, 1, negative 1, 3, negative 1, 10, negative 1, negative 8, and so forth. X is always negative 1. The y-intercept. Where do we find the y-intercept? C, right? 0, negative 8. So that's another point we can put on right here. We've got that point right there. And in fact, why not write that on here? We got a point. That's easy. We don't have to do any math there.
Will you accept that? Like if you had a test and we did that, like if you just throw it and don't put the
Yeah, because I just told you that. That's why I just said it.
Oh, okay.
Okay? Okay, so that's that point. Now we just got to pick some other points. So let's plug in 1. That's an easy point. So we're going to have 1 squared plus 2 times 1 minus 8. What's 1 squared? 1. Plus 2 is 3. Minus 8 is negative 5. So 1, 1, 2, 3, 4, 5. 1, negative 5 is right there. Now let's go the other direction. Let's plug in negative 2 and negative 3. So, negative 2 squared plus 2 times negative 2 minus 8. You can do this on the calculator, but you do it in your head. What's negative 2 squared? 4. What's 2 times negative 2? What's 2 times negative 2? 2 times negative 2. Negative 4. What's 4 minus 4? What's 0 minus 8? Negative 8. Oh, look, we already had a negative 8. But now it's over here, negative 2, negative 8. See how it's symmetrical? What do you predict negative 3 is going to give us? Probably. So negative 3 squared plus 2 times negative 3 minus 8. Negative 3 squared is? 9. 2 times negative 3 is? 9 minus 6 is? 3. Minus 8 is? Bingo, negative 5. And so then we take this and kind of, as carefully as possible, do this. As carefully as possible, do this. So Where does it look like approximately? Now, I did this a little bit wide, but where are approximately the x-intercepts? 1, 2, 3, 4. Maybe -4, 0, and 3, 0. Those are just approximates. I'm just approximating where they are. Now, domain. We already said this. Right, all real numbers. Good. The range. What is the y of the vertex? -9. And it's going which way? Up or down? So y is greater than or equal to -9. Okay, so we're going to do one more example here. Alright, so we want to start with our vertex when we're doing quads. So we want to start with our vertex, but first we really want to identify A, B, and C. Okay, so what's A?
2. -2.
-2. What's B?
4.
What's C?
6.
Okay. Now, I need that to find out the vertex. And remember, the vertex down here, x equals the opposite of b over 2a. So, the opposite of 4 over 2 times -2. So the opposite of 4 is -4. 2 times -2 is -4. -4 divided by itself is 1. So the vertex is 1 comma something. Okay? Remember, we put that in the middle. 1 comma something. Now we have to take that 1 and plug it back in here and here. So 1 squared is 1 times -2 is 2. I'll show the work here. So -2 times 1 squared plus 4 times 1 plus 6. 1 squared is 1 times -2 is -2. 1 times 4 is 4. 4 minus 2 is 2 plus 6 is 8. And you can just type this in your calculator if you need to, that's fine. Should be able to do it mentally in your head, but whatever. So that gives us a vertex of 1, 8. And I'm going to put that on right now. 1, 2, 3, 4, 5, 6, 7, 8. Now, common sense would probably tell you that we probably did not give you one going up, that high up, but it could be. You know, I could give you one that looked like this, you just don't have much to graph. But that is not the case. So it's 1, 8 right there. That's the vertex. Now, what tells me that this is a frown that's going down? Yes, sir.
It's most likely going down because it's so high on the
No.
graph.
That's just some common sense guessing.
I got it.
Yeah.
Negative.
Yep. A is negative. Okay? So if A is negative, it's going down. If A is positive, it's going up. Positive smile, negative frown is down. So we know it's going down. Now where's the axis of symmetry? Remember, go ahead and put that dotted line right there. That's the axis of symmetry. How do we get the line? That's x equals 1. And it's not that hard, guys. Look, it's literally just the x-coordinate from right there at the vertex. Every vertical line is x equals something. Now, where's the y-intercept? You already know the y-intercept. It's given to you. Look at your notes. At the beginning of the notes, it says where the y-intercept is. Which letter is the y-intercept? Which letter tells you the y-intercept? Well, you're on those. Yes, sir. Yes, but on here, looking at the original equation, which letter tells me the y-intercept? It is not B. It's C. Very good. This is the y-intercept. Guys, it's right on the first page. Okay? It tells you, down above, step 3. Find the y-intercept by looking at the C value. All the steps are right here. You should be able to look at this and find everything to do. So the y-intercept is 6. 7, 6, right there. So you have a general idea where that bad boy is going. Also, since we already know that, I'm just going to put 0, 6 right here. We don't have to do any work. But as he pointed out, the y-intercept is when x is 0. Let's see why it's c. If I plug a 0 in here, bye-bye. If I plug a 0 in here, bye-bye. All that's left is a 6. A 0 makes both the x squared and the x terms disappear completely. All we're left with is a 6. That's why c is the y-intercept. Because x has to be 0. Okay? And then we're going to put -1, we're going to put 2, and we're going to put 3. Now we just crunch the numbers. So -1, we put -2 here, -1 squared plus 4 times -1 plus 6. Now believe it or not, even on the graded worksheet, I'm still seeing people tell me that -1 squared is -1.
No.
It's +1. You were still saying that. So +1 times -2 is -2. 4 times -1 is -4. -4 plus -2 is -6. Plus 6 is 0. So here's my next point right here. -1, 0. And now I'm going to jump ahead here because, hey, guess what? My x-intercept, I already got one. It's not even an approximation. I know one of my x-intercepts is -1. It's right there. Now I'm going to do 2. -2 times 2 squared plus 4 times 2 plus 6. 2 squared is 4. Times -2 is -8. 2 times 4 is 8. So the 8's cancel, right?
Yes.
Leaving me just a 6. And hey, look at that. Remember that whole symmetry thing? So we're going to have 2, 6. And where do you think 3 is going to be?
0.
It is going to be symmetrically at 0, but let's prove it. -2, that's times 3 squared, plus 4 times 3, plus 6. Okay? 3 squared is 9. Okay? Times -2 is -18. -18 plus 12 is 6. -6 plus 6 is 0. So yes, we have a winner, and then we can draw our function like that. I also know for sure there is no estimating. I know my x-intercept right there. My y-intercept, I forgot to write that. We already got that. That's 0, 6. Bam. The domain, that's my x value. Here's another way to remember it. Does x come before y in the alphabet?
Yes.
Okay. Does D come before R in the alphabet?
Yes.
Okay. So X, D, Y, R. Domain has to do with the X values, left to right, and Y has to do with the range, which is up, down. Range is up, down. So domain, range. So the domain, how far is this bad boy going left and right? All real numbers, very good. Because it's going forever and ever. Range. Does it have a high point or a low point?
High.
Does it hit the ceiling or the floor?
Ceiling.
Ceiling. Where is the ceiling at?
Up.
Where's the ceiling at? It's at 8, right? Is it less than or greater than that? Which way is it going? Is it going greater or less than? Less than, right? So y is less than or equal to 8. In Algebra 2, you'll learn something else, but for now, in Algebra 1, that's what we're reading at. That's it. That's all we're doing. Okay, my bad, I botched it up. This is 3, 0. Clearly, this is 3, 0. It's not negative. I don't know why I wrote negative. It is 3, 0.